Hello everyone, Tara, this is our water filter. Today, we will be presenting our de-water filter project. In this experiment, we created a simple filtration system using basic and easily available material. The material used by us to create this de-water filter is cotton, activated carbon, sand, gravel, stones, dirty water from masjid, tap water from BAP, and methylene blue. At the bottom, we put cotton.
The use of the cotton. First, the cotton is used to filter the coarse sediment, protect other components, and improve the water purity. The benefits of the cotton is to trap very fine particles and also ensure that no fine sun grains or active carbon fragments escape with the treated water.
Next, followed by activated carbon.
Okay, for activated carbon, main function, this is the most critical layer for improving water quality. So the action carries out the process of absorption, and activated carbon has a fast porous structure that absorbs and remove contaminants that cannot be filtered physically. So this include residue chlorine, unpleasant odors, and taste organic pollutants like pesticides and coloration.
On third layer, we put sand.
Sand. Function of sand is to perform finer filtration. Its benefit is to move small particles, fluid, and other suspended solids that manage to pass through the gravel layer.
Fourth layer, we put a gravel.
Okay, next, I will explain about gravel. Gravel function as the center on the bedding layer to stop sand media from blocking. Its benefit include ensuring uniform water distribution and contributing to a longer filter life.
And last layer, we put a stone.
Okay, I will explain about stone. Stones are included in our water filter because it helps remove large particles such as leaf, twigs, and coarse seed. They also act as a support layer to prevent the sand and carbon from shifting or mixing. This keeps the filter stable and ensure the water flows properly through each layer.
Alright, to quantify the filter's performance, we use two main tests. First, the flow rate test. We measure the time taken for 50 ml of water to pass through the filter, calculating the rate in milliliter per second. Second, we analyze the change in turbidity, NTU, pH, dissolved oxygen (DO), and total dissolved solids (TDS) before and after filtration. So let's look at the flow rate. The BAP water filtered the fastest at about 2.92 ml per second, while the masjid water was the slowest, ranging only at 1.09 ml per second. This difference tells us the masjid water, despite our physical observations, contain a higher concentration of suspended matter that rapidly lock initial layers of the filter, showing the process significant. Stability is the most direct measure of particulate removal. Our result striking for the masjid water. The filter was incredibly effective. Stability dropped drastically from 160 NTU to 36.6 NTU, a 77% improvement, confirming the remove of sand and algae we initially observed. The BAP water also improved, going from 11.2 to 8.1 NTU. However, we had a major failure with the methane blue water. The turbidity increased from 5.72 NTU to an alarming 120 NTU. This indicates that the filter media, likely fine activated carbon or sand, was washed through the system. This failure highlights the filter's vulnerability when dealing with low turbidity or non-particulate contaminated water. Beyond clarity, we checked the chemical changes. Total dissolved solids or TDS showed a positive trend, decreasing for all samples. Example, BAP dropped from 18 to 10 mg per liter. This means the activated carbon and filter layers successfully removed some dissolved impurities. pH was mixed. The slightly acidic BAP and masjid water become marginally more acidic after filtration, from 7 to 6.6. This is a common side effect of using activated carbon, which can release trace acidic compounds. For the empty sample, the filter did not significantly correct its low pH of 5.17.
Here, you can clearly see the result of the water after going through our filtration process. From the tables and data, the best result is the masjid water because its turbidity dropped the most. BAP water shows only slight improvement since it was already quite clean. The worst result is the methylene blue solutions because chemical dyes cannot be filtered by a simple defilter. In conclusion, our dewater filter works best for water with many suspended particles like mustard water. It works a little for cleaner water like VAP, and it does not work for chemical solutions such as methylene blue. Our water filter can be improved by adding more filtration layers using finer sand, increasing the amount of activated carbon and making the structure tighter so no water leaks or bypass the layers. That's all from us. Bye-bye!
Kali ke berapa? Kali kedua.
Wait a minute. Who are you?